Hello, class. We just finished up our assignment in, let's just see right here, it was number 13, conservation of energy. So we ended up being able to come up with our initial velocity using this conservation of energy template, and we compared it to our initial kinematic, our initial velocity using kinematic equations. And so our percent difference was pretty low, and this is good. Now we want to interpolate. Now that we know what's happening at 90 degrees, we started off at 10 degrees, and not 10 degrees, what am I saying here? Oh my goodness. We started off at 0 degrees. I didn't have this up, but we started off at 0 degrees, and then we went to 20 degrees, and then we looked at 10 degrees, which should not be the same. It should be a little bit lower. Then we looked at 30 degrees, so 30 degrees should have a little bit more height. And then we had something like 45 degrees. This might be a little bit too big. But now we have 90 degrees. And so we interpolated between these angles, not necessarily in that order, but that's what we want to do now. And it's just to form a better, it's just to give us a better way to predict what's going to happen, to form a hypothesis based on what's happening. And this is really just in the lab. If you take it outside, hey, things change. So let's just go ahead and go to Dropbox. And under Dropbox, you'll see that we have our COE, alternative hypothesis. And I'm just going to open this in Microsoft Excel. So here it is in Microsoft Excel. We have our initial velocity. So we actually need the data set for our initial velocity. The prediction page is just referring to what's happening on the initial velocity and the verification page. So we're going to need to get our data for both of these. And our interpolation from 0 to 20 takes place first. And then we have our extrapolation. We don't necessarily have to have all of this in here. I could just go to alternative. And then we have extrapolation, but we build on top of each one of these. And then finally, we will have our alternative hypothesis, which right now is, even though there's an equation here, this equation doesn't fit because the data is not in. You have a bunch of divisions about 0. So let's just go ahead and get our data set from, and I need to go back into this. Let's go to initial velocity. Initial velocity is right here. And I want to acquire the data collected. Now, if you didn't do it like this, all I'm really concerned with is the data. It's really what I'm concerned with. And so I'm going to duplicate this. You guys could always copy it from Dropbox, from one folder in Dropbox to another folder. So that's a nice new feature, but you can duplicate it as well. And I want to put this into 14. So just to kind of focus and bring scope in. These are the things that we're going to be working with. So not only do we need that, but we also need our prediction, our verification data. And so I'm just going to select one of these CMBL files that you see here. You should only have one. I'm going to take the CMBL file into this interpolation folder and just paste it. Okay, so both of those files are there. I want to go back out. The first set of data that I want to take in is the initial velocity data. So if I just go back into 14, you'll see we have our initial velocity data. Just to move from left to right, don't have to do it like this. So I'm just going to go ahead and collect this. And hopefully it's already clean. In other words, we've already checked the data set. It's good. Okay, there are no extra zeros, no extra 0.40s. And I'm just going to go ahead and paste that into B and C. Now we can check our data. We have about 4 here, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4. So that lets us know our data is pretty good. We're getting the same calculation here for the initial velocity. Okay, now we need to go back and get our verification data. And here's our verification data. I'm just going to tap on B, copy, since it's already selected. Just make sure you highlight both of them. And then go back to the COE. And we want to go to our verification page here. And I'm just going to go ahead and paste this in. And again, you'll see that we have all positive 0.8s over here and all negative 0.13s over here. And that's what we want to see. And we see our averages here. So if we go back to prediction, all of the numbers are filled in. Our prediction is good, still based on what we did last time. And then we have our verification. Then we have interpolation. Interpolation still looks good. It's between, I'm moving the wrong screen. It's still in between 0 and 1. It's going between 0 and 20. So that's really good. And then we have our extrapolation. This should have an equation on there. Very good. And then we're going to go to our alternative hypothesis. So in this particular case, you'll see that all of the data is here. And we go from 0 all the way out to 90 degrees. Okay? We interpolate between several values. We go between 0.081 to 20, to 2.1515, and that's at 20 degrees. And then at 30 degrees, we have, this is 40, no, this is at 30 degrees. Then this one is at 45 degrees. It's 0.189 meters. And then at 20 degrees, we ended up with 0.23 meters. Okay? And so with that information, we were actually able to predict quite a few things. And we came up with a line, an equation of a line. So we have this straight line, and this is the equation for the straight line. It's y equals to a negative 0, 0. This doesn't fit. It's just from the first 20 points, from 0 to 20. And so that line is no longer valid in this particular case, except for between 0 and 20, and it wouldn't be sloped like that. It should just be this set of data points. So, and now we have all of these data points going across like so, and we can form a trend line, and you'll see the trend line is close to our what do you call this? Our data, our interpolated set. And so we have an equation that allows us to predict where a ball is going to land. So if I just reduce this a little bit, you'll see that we can go at 0 degrees, we're approximately at, that means that x is 0, that means we're at 0.32. But we know that we're really at about 0.39, okay? So that's some error that's introduced into that equation. And then as you go up, you go around 20 degrees, then you go to 45. That's the maximum that you can have for your projectile. And then at 90 degrees in the x direction, you actually have 0. And that's pretty much the end of this video, this talk.